Right, so in this video I'm just going to have a look at questions 10 and 11 from Junior Cert Higher Level Maths Paper 1, 2017. So first part of question 10 involves writing each of the following in the form 2 to the power of n, where n is a rational number. So in the first case here we've got 2 to the power of 3, 2 to the power of 3 times 2 to the power of 5 times 2 to the power of 10. And first law of indices from your tables would just say that you add the powers here. So it's going to be 2 to the power of 3 plus 5 plus 10, so that will just give you 2 to the power of 18. So that's the first part. Second part here is we have 8 to the power of 25 here. So we got to change this into 2 to the power of something. Well, 2 to the power of 3 is just the same as 8. So this is just 8 to the power of 25. Another rule of indices here is when you've got a power here, you just multiply the two powers. So 3 25s, 75. So this is our answer here. Third part, we have the square root of 8. Well, so we have the square root of 8. Well, that's just 8 to the power of a half. And similar to the previous question, 8 is just 2 cubed. So that's 2 cubed to the power of a half. And again, similar to the previous question, when you've got a power, you multiply the two powers. So we get 2 to the power of 1.5, or 2 to the power of 3 over 2 is usually the way you would write it. 2 to the power of 3 over 2. Okay, so that's the first question. Let's have a look at the second one here then, question 11. So this just involves a linear sequence. The second term is 40 and the sixth term is 116. Fill in the boxes below to show the rest of the 6 terms. So we're told that this is linear. So now, I mean, you could try and guess the numbers in between here. It might take you a little while to do it. But one way you could do this is, you know that T2 is equal to 40. And you know that T1, 2, 3, 4, 5, 6, sixth term is equal to 116. Now, from your tables as well, you should know that Tn is equal to a plus n minus 1 times d for linear sequences or arithmetic sequences. So in other words, we can write 40 is equal to a, which we don't know. N in this case is 2 minus 1 times d, the difference we don't know either. Also in this case we've got 116. 116 here is equal to a plus, now 116, n is actually 6 here, so it's going to be 6 minus 1 times d. So we have two equations here, we have two unknowns, so these are our two equations here. So we can use simultaneous equations to work out what a and d are. Well, let's take them separately. I'll just multiply them out here. The first one, 40, is equal to a plus, well, 2 minus 1 is 1. 1 times d is just d. So that's equation 1. Second one, 116, is equal to a plus 6 minus 1 is 5. So we have 5d here. That's equation 2. Now, looking at these two, what I'm going to do here is try and cancel the a's here. So I'm going to take equation 1 and I'm going to multiply it by minus 1. So I'll have a minus a and a plus a. So that'll give me minus 40 is equal to minus a minus d. And equation 2 then will just simply be 116 is equal to a plus 5d. Now I can add these two equations. Here I'm just going to get 76. 76 here. Here minus a plus a will give me 0. And I'll have a plus 5d minus d, that just gives me a plus 4d. And here then you can just divide by 4, so that gives me d is equal to 19. So now I know what d is. d is 19. Perfect. So let's have a look. We'll have a look at equation 1 here. We have a plus d is equal to 40. This is equation 1. We now know what d is, so a plus 19 is equal to 40. So that gives me a is equal to 40 minus 19, which is 21. So now I know what A is. A is the first term. So if I take the first term here as being 21, so I'm going to write 21 in here. Add 19, remember my common difference is 19. So add 19, I'll get 40. Add 19 to 40, you get 59. Add 19 to 59, you get 78 here. Add 19 to 78, that's 88, 98, 90, sorry, 78, 88, 98, 97, yeah, 97 here. And if you add 19 to 97, you do get 116 as well. So okay, that seems to work. So that's our new sequence, or that's our completed sequence, I should say. Fill in the box below to show the rest of the 6 terms in this sequence. So we've done that. Okay, so let's have a look at the next part of this question here. We have Orla. She's asked to write down a quadratic sequence, and she writes down these numbers here. Exactly one of the terms in Orla's sequence is incorrect. So one of these terms along here is wrong. Write down the correct sequence in the spaces below. You may only change one of the terms. So let's have a look at them. You have 5, 6, 9, 14, 22, 30, and 41. Now, if this is a quadratic sequence, usually the way we do this is we look for the first difference, and the second differences should all be the same. We look for the first difference first. So 5 up to 6 is plus 1, 6 up to 9 is plus 3, 9 up to 14, that's plus 5, 14 up to 22 is plus 8, 22 up to 30, that's another plus 8, 30 up to 41, that's plus 11. So let's go again. This is quadratic, so the second differences should be the same. So let's see what our second differences are. Well, here we got a plus 2, which is fine. This is 3 to 5 and another plus 2. That's perfect so far. Now we have 5 up to 8, so that's plus 3. So there's something wrong here. 8 up to 8 is plus 0, and then 8 up to 11 is plus 3. So there seems to be a problem, I would think here. There's a problem here with this 22. We need to reduce this down. I'm thinking 2 is going to be our second difference, so we need to reduce this down to plus 2, which means this would have to be, the difference between 5 and 7 would be plus 2, so that means this would have to be not a plus 8 but a plus 7, which means this here would have to be 21. So I'm thinking this would be 21 here. So this here I think is my problem. Let's just try that. We can try it out. If it works, fine. If it doesn't, we can have another we can have another look at it. So let's have a look. We have 5, 6, 9, 14, and then this is going to be 21, I'm saying. This is 30, and this is 41. So if we were to do this, we would get, we'll do the first differences first. So first difference, 5, 6 is plus 1, 6 up to 9 plus 3, 9 up to 14 plus 5, 14 up to 21 plus 7, 21 up to 30 plus 9, 30 up to 41 plus 11. Now if we were to do second difference then, let's have a look at our second differences here. 1 up to 3, that's plus 2. 3 up to 5 plus 2, 5 up to 7 also plus 2, 7 up to 9 plus 2, 9 up to 11 plus 2. So our second difference is the same, so this is our new quadratic sequence here. So that's really all we were asked to do. Write down in the correct in the space below. Okay, so in the actual question they gave you some boxes to put in these numbers, but I'm not going to do that. We have them here. This is the actual answer here. Okay, so that's it for questions 10 and 11.